Okay, there are 3 tools we've learned over the last year that we need to be able to use in terms of the AP test. We've learned to take a derivative, we've learned to take an integral, and we've learned to solve. Okay, so for Casios, I'm going to go ahead and review each of those 3 tools here. This document is created in a way where we will do one of the problems together, and then there are between 2 and 3 more that you can use to practice if you choose. So for example, in this first set, I'm going to use number 4 here to review how to do it. And then if you would like to practice this some more, you've got numbers 1 through 3. If doing number 4 was enough of a review, you can move on. And I'll do that for each, right? I'll do that for integrals, and I'll do that for solving. Okay? So derivatives, up first, we've got number 4. To take a derivative in a Casio, you're going to go to your run here. And a derivative is under option. So you're going to go option. There's calculus, so you're going to hit F4, and derivative is here. Okay, to calculate your derivative, you're going to start by plugging in your function. So we've got our 3x minus 56, that's my numerator, divided by the square root, there's square root right there, of x squared plus 3x minus 7. And once you've typed in your function, you're going to do comma, and then whatever the value is you're trying to find your derivative at. In this case, this is 10.27, so you're going to go 10.27. And when you hit enter, it'll tell you 0.4655. Okay. Okay, so there are 3 more here if you would like to practice that. Integrals. Integrals, I'm going to go ahead and use number 4 to review integrals because it allows me to review 2 things, absolute values and the integral. Okay, so for Casios, again, you're going to go ahead and go to your run screen here. So let me actually back all the way out so we were to start fresh. Okay, we're going to go to our run screen. Again, you're going to hit option, and integral is under calculus. There's your integral. Okay, we've got to go ahead and type in our absolute value now, so I'm going to back up again. Absolute value also is under option, but for absolute values, you want to look under NUM, numeric or number. And there's ABS for absolute value. Okay, typing it in, we're going to have our cube root of x cubed minus 1. So we've got x cubed minus 1 raised to the 1/3 for that cube root. Okay, so that's my function. And then we're going to go ahead and do comma our lower bound, which is -2. Comma our upper bound, which is 4, and when we hit enter, it'll take a little bit. You can see it's thinking. There's that little box right there. Again, you'll have to give it some time. Taking a good little chunk of time, isn't it? Which does sometimes happen, even on other calculators. This took a little bit to get. There we go. Sorry, that took a little bit longer than I was anticipating, but it got there. We got our 10.8017. Okay, so that's an integral. I'm not sure why that one took so long, but there you go. It still gave it to you, right? So it's a good lesson. It's not, sometimes you might have to sit for a little bit, but it will eventually give you your answer. Okay, so if you would like to practice that on any of the other integrals, you can. There are 3 more here with corresponding answers. Okay, our third and final tool is solving. Now, solving is a pretty big tool. Honestly, it can be used for just about any time you have a function in some way, shape, or form, 2 things that are equal to each other that you are trying to solve. So that function could be the result of a word problem, it could be mean value theorem, it could be maybe you're trying to find relative extrema, particle motion, I don't know, right? It could be anything. Okay, but you've got two things equal to each other and you're trying to solve for x. Okay, so I'm going to use number 11 to model this. Number 11 says particle A has a position given by this function. For the record, these should be t's. Same thing over here. Okay, where we have this position function, 1/3 t cubed plus 3t minus 5, and velocity given by the quantity of 1 plus t cubed raised to the cube, raised to the third, all over 3. At what time do the two particles have the same acceleration? Okay, so particle A with its position function given, its velocity function would be the derivative of position, which in this case would be t squared plus 3. Acceleration would be the derivative of velocity, which would be 2t. So that's one of the accelerations. I want it to have the same acceleration as particle B. Particle B's acceleration, which is the derivative of the velocity, would be bringing down that 3, the 3's would cancel, leaving the base alone, subtracting 1 from the exponent, times the derivative of the guts. And I want those two accelerations to be the same, 2t to equal my 3t squared times 1 plus t cubed quantity squared. Okay, so once you have an equation, right, the equation being generated from whatever you're trying to solve for, the first step is to get that equation to equal 0. Okay, so I'm going to go ahead and subtract that 3t squared 1 plus t cubed quantity squared over to the other side. And once it equals 0, I'm going to graph that function. Okay, so in our menu here, we're going to go over to graph, and we're going to type in our function, 2t minus 3t squared times 1 plus t cubed quantity squared. Our window can be whatever we want it to be. I made mine fairly large, -10 to 10, but again, you could do whatever you wanted. And drawing that, give it a little bit. There's my function. Okay, which actually now that I look at it, I'm like, that's pretty zoomed out. I think I'm going to go ahead and adjust my window and maybe make it come in a little bit closer. Maybe I'll do -3 to 3, just so I can zoom in on that spot. Whoops. Zoom in on that spot. Where it looked like I was touching the x-axis. My goal here being I want to see, do I touch the x-axis more than once? So I'm going to zoom in so I can see. And sure enough, when I zoom in, I do notice I touch my graph more than one time. Okay? So to find those two locations on a Casio, you're going to go to G-solve. It's yellow, so you're going to go shift there. And yours is called root. Give it a little bit. Eventually you'll see a little cursor, kind of like a little Pac-Man traveling along this graph, and it'll stop at that first 0. There it is. And my first 0, it tells me, is at x equals 0. And then to get to that other place, I'm just going to hit my side arrow here. I'm going to go over. Just going to move on over to .515, which is this other value. And you've got your two places where you've touched the x-axis, you've solved for x, or in this case t, I guess technically speaking. And again, you can do that anytime you are trying to solve for some variable given some equation. Okay, so you have 9 and 10 here, which are designed to be extra practice if you so choose with their corresponding answers. But that's your third and final tool.